So we're trying to start permutations and combinations. This is a prerequisite and important topic to understand probability later. So probability, as you might know, that probability is used in everyday life. It's a very important topic, trying to calculate chances of an event, how much likely it is, or what's the likelihood of an event happening. But to understand probability, you need permutations and combinations, which is basically in how many ways a letter or a word or a number can be arranged. So we are basically trying to count all the possible combinations of a thing that can be arranged. So moving on to the questions are very easy. And the first question is, we are looking at a word, smart. So this is a pretty easy word. It's just a 5-letter word, and none of the letters are repeating. All the letters you can see S, M, A, R, T are non-repeating. All of them are non-identical. All of them are different, basically. So the easiest way you can do this, first we can use the formula, is just you can say that this is a 5-letter word. So the number of possible ways that this can be arranged, how many different ways this can be arranged, is just 5 factorial. And factorial, if you don't know, it's just notation for the product of all the digits or numbers below that number. So 5 factorial is basically 5 times 4 times 3 times 2 times 1. So that's basically 5 factorial. Or we can also use the notation. This is not pi, this is basically the product of all the numbers up to that number. So like we use summation for sum, so you can use this pi letter for the product. So this is basically just of 5. So basically the product of all the numbers up to 5. But this is the easier way we say that of a number is n factorial, which is the product of all the numbers up till n. So we denote that by factorial. So coming back to the question, smart is a 5-letter word. So basically all the ways that it can be arranged, meaning if I change all the letters around and how many different combinations come out of this, is 5 factorial. So 5 factorial is basically just 120. If you try to compute this product, 5 into 4 into 3 into 2 into 1, which is 120. So the answer is basically C. Now let me explain this the intuitive way, how you can intuitively think about this. So basically what we're trying to do is that this is the word that we're trying to arrange in all the possible combinations. So you can see that first letter is S. Now I can use any letter as the first letter basically. So I can do this. Basically I have all the 5 choices open for the first letter. But when I fix the first letter, what you understand is that for the second letter I only have 4 choices because I've already fixed one letter. So for the second one I will only have 4 choices. So you can write this as 5 into 4. And then you can just go on from that logic that for the third letter you will have 3 choices. And then so on for the fourth letter you will have 2 choices. And then obviously for the last letter you will only have 1 choice because you have already fixed the first 4 letters and then you only have 1 choice remaining. So this is the way we actually intuitively think about this. So this comes around to again 120. So that's how many possible combinations or number of different ways you can arrange this letter. So moving on to the next question. So next question is about the word formulate. I'm just writing the word first. Formulate. So it's the same logic. It's just that the previous word was a little bit shorter, smart, 5-letter word. Now this is a 9-letter word basically. So you will just say this is 9 factorial. So now you can see at the answers, obviously they are bigger. The problem with probability and permutations and combinations, these type of questions, is that you're talking in factorials, you're talking in products, not sums. So as you can see, the product can quickly scale up to very large numbers, maybe millions or billions. So I don't expect you to calculate 9 factorial or maybe in 15 factorial, but what you can do is you can use common basic number sense that previously we calculated 5 factorial, which was 120. So naturally 6 factorial would be 720. And then you can say maybe you can calculate up to 1 more number higher is 7 factorial, which is 5040. But you can see that these numbers quickly scale up very fast because it's a product. So it's exponentially growing. So then it becomes a little tricky. 8 factorial, maybe you can just say that this is 5000. You can use approximation. 5000 into 8 is around 40,000. So 8 factorial is this. But that's not the answer because we have 9 letters. So we're trying to calculate 9 factorial. So 9 factorial, you can see that, okay, by approximation, you said 7 factorial was, let's say, 5000 times 8. 40,000 is somewhere close to 8 factorial. And then you say 40,000 times 9, which is 360,000. So this would be approximately 360,000. Now you see any answer that's close to this number is basically D. It's a little bit larger than that because we were trying to use round off numbers. We rounded off this to 5,000, this to 40,000. So answer is little bit bigger than this 360,000. So this is the way you can, approximately calculate very large numbers. So this is the answer. And then we'll move on to the next lectures. In the next lectures, the trick that you can identify is that, some of these letters will be repeating. So let's say I put another E here or maybe another vowel here, and then it's a little bit tricky. Obviously, the number of permutations shrinks because some of the letters are repeating. So we'll see how we do that and think about it in an easier way. So this is the first lecture is wrapped up and pretty easy so far.